Section 3.3 is on slopes of lines. And you will recall from Algebra 1 that the slope is a number that measures the steepness of a line. It is the ratio of the rise, which is the change in the y values, to the run, that's the change in the x values. And this little formula here should look familiar from Algebra 1. M, which we use for the slope of the line, is y2 minus y1 over x2 minus x1, where m is the slope of the line that goes through the points x1, y1 and x2, y2. To classify slopes, if the line looks like it's going uphill as you read from left to right, it has a positive slope. If the line is going downhill as you read from left to right, it has a negative slope. A horizontal line, this perfectly horizontal, has a slope of 0, m equals 0, and a vertical line has an undefined slope. There's not a number attached to it. I discourage you from using the term no slope. You may have learned that in a previous class, but to me, I don't quite understand what that means. It's either 0, or it is undefined, or it's a number. Okay. Let's do a couple examples here. Let's determine the slope of the line through each pair of points. If it helps you to do this, to label this x1, y1, x2, y2, go ahead and do that. If you found that helpful when we were doing midpoint and distance, please do it here. So the slope is going to be the difference of the y's, and you can actually do y2 minus y, you could actually do it the other way around, y1 minus y2, but just make sure you subtract your x's in the same order. So I'm going to do negative 5 minus a negative 2, be careful with that, minus a negative, over negative 3 minus 6. And remember, minus a negative becomes plus a positive. So my slope here is going to be a negative 3 over, negative 3 over negative 9. Reduce that fraction, so my slope is 1/3. And you'll remember from graphing lines, most of the time we like to leave our slope as a fraction because that helps us when we go to graph. Example number 2, 4 comma 2 and 4 comma negative 3. So let's subtract our y's, negative 3 minus 2, over, subtracting our x's, 4 minus 4. And that's going to give me a negative 5 over 0. And you'll recall from the first commandment of math that thou shalt not divide by 0. So this is not a number that we can use. It is not equal to 0. This is a case where we would say that the slope is undefined. If I were to graph those 2 points and draw the line through them, it would be a vertical line. In our last example here, negative 3 comma 3 and 6 comma 3, I'll do subtract my y's on top, subtract my x's on the bottom. That's going to give me a 0 over 9, and that one is indeed equal to a 0. If that's something you need to memorize, let's do that right now. A 0 on the bottom is undefined. A 0 on the top, no matter what's on the bottom, well, it can't be a 0 on the bottom, but a 0 on the top and a non-zero number on the bottom is always going to be equal to 0. And that's a horizontal line. You'll also recall from Algebra 1 that if two lines are parallel, they have the same slope. So the slopes of parallel lines are going to be the same, and the slopes of perpendicular lines are opposite reciprocals of each other. So if the slope of one line is 4, the slope of the line that's perpendicular to it is going to be a negative 1/4. So flip to fraction and change the sign. And here's an example. Determine whether lines AB and CD are parallel, perpendicular, or neither for the following coordinates of points A, B, C, and D. So the first thing we need to do is find the slope of each line. So the slope of line AB is equal to 0 minus 13 over negative 11 minus 14, or a negative 13 over negative 25, or 13 over 25. So that's the slope of line AB. Now we're going to find the slope of line CD. Line CD, I will do -5 minus 7 over -4 minus a -3. And that gives me -12 over -1, or a slope of 12. So, looking at the slopes of my lines, the slope of AB is 13 over 25. Slope of CD is 12. So the slopes are not the same. Therefore, they're not parallel to each other. The slopes are not opposite reciprocals. Therefore, not perpendicular to each other. So my answer is neither. Since the slopes of the two lines were not the same, the slopes were not opposite reciprocals. If I flip 13 over 25 and change the sign, I don't get 12. So in this case, it would be neither. Okay, so next example says, graph the line that contains the point A, which is -3, 0, and is perpendicular to line CD with point C, -2, -3, and point D, 2, 0. So the line is going to go through the point -3, 0, which is right here, and it's going to be perpendicular to line CD. And actually, I don't need to graph line CD, I just need to find its slope. So let's find the slope of line CD, and that's going to be 0 minus a -3 over 2 minus a -2, or a slope of 3/4. So the slope of line CD is 3/4, but I need the slope of a line perpendicular to that. So slope of the line perpendicular to line CD is going to be the opposite reciprocal of 3/4, which is -4/3. So I have one point on the line I need to graph, and that's the point right here, -3, 0. And I'm just going to use my slope to move and graph a couple other points from that point. So recall that a slope of -4/3 means I can go down 4 and right 3. So -4 over 3 is down 4 and right 3. Suppose I would put the negative on the bottom. That would mean I go up 4 and left 3. And there is the line that is perpendicular to line CD with those given points and passes through the point A, which is -3, 0.